This tutorial will show how to use SAP 2000 to model a cable-stayed bridge using staged construction. It will have two spans, each 100 meters in length, with a single steel pylon 60 meters tall. The deck will be a concrete box section, 6 meters wide, and will be constructed in 10 stages. We start the process by clicking on File, New Model, and selecting the units as kilonewton meters. We will construct the model using only grids, so click on the Grid Only button. We will have a total of 3 grid lines in each direction. Click on the Edit Grid button to bring up the grid data form. For the X direction, which is along the span, our coordinates will be -100, 0, and +100. In the Y direction, which is across the deck width, we will enter -3, 3, and 0. In the Z direction, which is vertical, we enter -10, 0, and 50. We will work in only one window, so close the Plan View window and go to the Define Frame Sections command. Here we will add pipe sections to define a non-prismatic pylon. We start with the bottom section. Make sure that the material is set to steel and enter 1.2 meters for the diameter and 0.05 for the thickness. We will add another pipe section to model the pylon at the top. Here it has a diameter of 0.6 meters and again a thickness of 0.05. Next, we will take the sections just defined and create a non-prismatic section. We will call it Pylon and use the top section as the start section and the bottom section as the end. It will be varied over the entire length in a cubic variation. Next, we zoom in on the pylon location. We will draw the pylon object, starting at the top and going to the bottom to match our member definition. We leave the Draw mode and shut off the grid lines under the View menu. Next, we will draw joints to model the saddle locations for the cables. The first joint will be 4 meters below the top of the pylon. By clicking on the top of the pylon with the offset set to -4 meters, a joint is added. We leave the Draw menu, select the joint just drawn, and go to the Edit Replicate command. Here we will add additional joints for the saddles at 2-meter intervals below the selected joint. This gives us a total of 9 cable to pylon connections. Next, we will modify the concrete material property to include time-dependent properties. In this model, we will include both creep and shrinkage effects. We will set the shrinkage start age to be 3 days, and will use the full integration creep analysis type. Next, we will define the concrete box girder to be used for the deck. Select the material to be concrete and input a depth of 1.2 meters, a width of 6 meters, a flange thickness of 0.2, and a web thickness of 0.3. Toggle the grids back on and switch to an XY plan view. And toggle down to the Z equals 0 level, which is the elevation of the deck. We will draw the deck as a single object. From the pylon out to the right end of the deck. Click on the Select Mode button and select the frame object just drawn. Go to the Edit Divide Frames command and enter 10 to divide the deck into 10 segments. Next, we will define rigid links that span from the deck centerline to the deck edge where the cables connect. Click on the Fix All button to restrict any relative deformation. Before we draw the links, we will turn on the Snap to Lines option and we'll window in for a better view. Click on the Draw Two-Joint Link command. Select Rigid Link from the property box and click on the first joint to the right of the origin. Select Vertical from the Drawing Control box and click on the top grid line to draw one link. Right-click the mouse to stop drawing and repeat the process for the rigid link on the other side of the deck. Zoom in even closer and select the two rigid links just drawn and go to the Edit Replicate command and add links at 10 meters on center. Isolating our view on the right side of the bridge, next we will define the cable sections. Go to Define Cable Sections and add a new section. We will define the properties by using a diameter of 0.04 meters. Next, we will draw the cable objects. Make sure that Cable Object Type and Cable Section is selected. Draw the cable from the lowest saddle point to the end of the first bridge segment. The parameters for cables form will automatically open. Verify that the number of segments is set to 10 and that the cable type is set to undeformed, as we want the cables to be taut. Repeat the process for the next cable, going up one saddle point and out one bridge segment. Continue this drawing until cables have been added all the way out. Next, select all the cables and assign a P delta force of 10. Again, select all of the cables, and this time go to the Edit Replicate command. We will use the Mirror tab and mirror the cables about the plane parallel to X to create the cables on the other side of the deck. Now select the entire model and click on the pylon to unselect it. Again, click on the Edit Replicate command and then on the Mirror tab. But this time, click on the mirror about plane parallel to Y. This will replicate the cables and deck on the left side span. To enhance the view, we will select the Extrude View option. We will also turn off the grid lines and display the model in full 3D. Next, zoom into the base of the pylon so that we may assign support restraints. For the pylon, we will fix the base to restrict all translation and rotation. We will turn off the extruded view so that it will be easier to select objects. Next, we will select the right end of the bridge and assign a pin support. We will assign the same pin support to the left end as well. Next, we will assign objects to groups that will be needed to define the segmental construction. Start by switching the view to an XZ plan and selecting the pylon. Go to the Assign to Group command and add a new group called Pylon. Next, select the deck segments just to the right and left sides of the pylon, along with the accompanying cables. There will be 4 cables in all, and assign them to a group called Deck 1. This will be the first deck construction segment. Repeat this procedure for the next group of decks and cables. And continue until all 10 deck sections have been assigned to a group. The next step is to define the analysis cases, which is where we will lay out the sequence of the staged construction. We will add a new case, and make sure that nonlinear stage construction is selected. And click the Add button to add a stage. This first stage will be the pylon. Typically, we will use a duration of 3 days. Under the data for stage 1, select Add Structure for the operation. Select Pylon for the group, and use 3 days for the age. In addition to the structure being added, we will also add load for this group, with the load equal to twice the dead load. Now we will add another stage, this time for the first deck sequence. Under the data for stage 2, again we add structure as well as load on the group. Repeat this process until you have created stages for all of the deck. In addition, we are adding stages after the construction to display the effects of time. Our last stage has a duration of 3,000 days. Note that the stages for each step of deck construction have been created, and that the stages created for the time effects have a varying duration. Older concrete is less sensitive to time and thus may have a longer duration step. It is important to realize that stage duration can have a significant impact on creep calculations. Click on the Modify Show button for results saved and make sure that there are an adequate number of steps assigned for the time-dependent items. We will use 5 for this model. Lastly, on this form, click the Modify Show button for the nonlinear parameters and make sure that the P delta option is selected. Now we are ready to run the analysis. For this model, we will not run the modal case. The analysis window shows how the program steps through each stage. Once the analysis is complete, we can display the moment diagram in the deck for a particular step. For the step we selected, step 30, the bridge is only partially completed. We can create a video showing the bridge construction sequence along with the varying moments in the deck, including both construction and time effects. Now we'll switch to an undeformed shape. Next, we will display the longitudinal deflection of the deck mid-span versus time. The point selected is joint 46. For this plot, we will limit the horizontal time axis to 300 days. Next, we will plot the axial force in 3 cables as it varies with time. For this plot, we will limit the time axis to 36 days. It is easy to see the 3 distinct starting times for the 3 cables. Lastly, we will plot the moment midspan as it varies with time. This concludes this tutorial.